All right. Hoping I'm doing this. Now it's going to say that. All right. So we're just going to review some of these topics, and if you have any questions, just let me know. So with sensation and perception, we have psychophysics, which this is basically, honestly, I'd be surprised if this was on here, but this is just the scientific study of sensation and perception. Okay. And then two, also, if any of you wanted to open up the presentation, this is in the AP exam folder, and you could open it up and take notes along that way too if you prefer. Okay, so I think the big thing here with sensation and perception that I'm seeing the confusion is that sensation is the meaningless bits of information, so it's all the information coming from our environment, and perception makes it a meaningful whole in the brain. Okay, so that's going to be the big difference, which then connects to this. I really feel like there's always a bottom-up or top-down processing question, or quite frequently. So bottom-up tends to be more sensation. Okay, so taking sensory information and assembling it up to the brain. Okay, and then the top-down processing using models, ideas, and expectations. And some of that is going to come from the association areas in the various lobes. And these are learned from experience. This is learned from prior ideas and influences. So for example, okay, the example I like best is your favorite food. So mine is my grandma's pistachio pie. Okay, so the bottom-up processing would actually be the texture, the taste buds being activated. The top-down processing is knowing that it's my grandma's pistachio pie. My grandma made it, so it tastes better than when I make it, okay, because of that prior expectation. Are there questions on that? Overall, you can tend to think sensation, you can tend to think perception, but they definitely both are a part of sensation and perception. Okay. So now what we're going to get into is looking at kind of the key components of the of sensation and perception. So sensory adaptation is when you get used to a stimulus. So it's going to be something that you see, that you hear, that you touch. It has to do something with the senses, and you adapt to it. So like my watch, I don't think about my watch all day. Okay, I have adapted to it. How many of you have, when you're listening to music, you slowly turn it up? Okay, and then you go and put your earbuds in after taking them out, and it's super loud. Okay, you've gotten used to the sound. So how is this different than habituation? Habituation has to do more with cognition and boredom. Okay, so this is going to be that you're not responding to the stimulus because you're getting more bored, or you get used to the stimulus itself. So it's not like they're adapting to the vision here. Okay, like the brightness of the lights or something like that. They're actually getting used to the scarecrow being there, and now it doesn't give the same effect. So habituation is more cognitive. This is sensation and perception. That oftentimes is a confusing pair. Okay, and then the absolute and difference threshold. I really liked this example a lot. Absolute, the big thing is the absolute is when you first detect it. The difference is when you can tell the difference between the two. Okay, so here, I first detect this, and what's that weird part of the definition? It's not just when you first detect it, but what percentage of the time? 50% of the time. Okay, when you detect it, 50% of the time. So here you have the absolute threshold is going to be the candle flame, okay, that I can see it 30 miles away, but not 31. And then here, can I tell the difference between the blues? Okay, and also too, if you, people coming on in, if you want to open up the presentation and take notes along there, because I know I'm moving pretty fast, that might be a way to kind of take along, or just sit and listen, and I'm recording it right now too. Okay, so the big thing here, there's two concepts I want you to know that are associated with absolute and difference threshold. Okay, with absolute threshold, there's something called signal detection theory. So signal detection theory is going to be adding a cognitive element into absolute threshold. So if I have a lot of noise, I'm listening to music in my room, but I'm expecting a phone call. Okay, the music's probably louder than the ringing of the phone. Okay, but I may hear that ringing of the phone because I'm expecting it. It doesn't make sense for a new mom to sleep through an entire thunderstorm but then wake up to a slight whimper of her baby. Okay, that again is adding the expectation. The storm is significantly louder past our threshold, but we added in that expectation. And then the difference threshold is Weber's law or Weber's law. Okay, and that's going to be that they have to, the difference between the two, the more intense the stimulus, the more of a difference there has to be. Okay, and then there's that. Okay. Have a good day. Okay, so the subliminal threshold is going to be when it falls below 50%. Okay, so when it falls below 50%, it's below our threshold. Okay. Where transduction is the changing of sensory information. Where does transduction take place in the eye? The what? Before that, the retina. Okay, so the transduction takes place in the retina. Okay, where is it? So it goes retina and then to the nerve. Where does it take place in the ear? The cochlea. So those two I definitely want you to know. Okay, transduction, so it changes from light waves to neural messages in the retina, and then it changes from sound vibrations to neural messages in the cochlea. And then here, I did find an assignment for tomorrow is just going to be looking at a variety of mnemonic devices that I have and seeing what works for you. Okay, and then you can ask any questions of those at the review Wednesday or Thursday. Okay, so overall, the big parts that you need to know is the cornea, pupil, which is regulated by the iris, and then the lens, which bends and focuses light onto the retina. Okay, and then the concentration of cones is that fovea. Okay. So which of these eyes do you think is in a bright room, the left eye or the right eye? Yeah, the one on the left. So the iris regulates the pupil. When it's dark, okay, our pupil gets bigger and then we adapt. So we've seen accommodation a few times in this course. So accommodation means change. So when we're talking about it with sensation and perception, the lens accommodates to objects that are far and near. We talked about it yesterday with development. Okay, if I'm changing something, I'm changing my schema. Okay, so accommodation has to do with change. It just depends what unit you're looking at. Right? And I did find a really cool mnemonic device to help remember this with the rods and the cones and the bipolar and ganglion cells, so definitely check that out. When we look at the rods and cones, okay, which one needs light? Cones, and remember the 3 C's, color, clarity, located in the center. Okay, so the cones see in color, they see clarity, so they allow us to see a visual acuity. And then they're in the center of the retina, and that's called the fovea. So that means the rods are the opposite. Black and white, periphery, blurry. So the blind spot, these are all photoreceptors here. Okay, where the nerve leaves the eye, there can't be photoreceptors, otherwise it'd be blocking the nerve leaving the eye. So that's that blind spot. Do you remember that XY activity that we had done? Okay, in class where we covered one eye and then the X disappeared. So now we're going to move a little bit more into the brain. Feature detection cells I would note this. I don't know why, but this seems to be a favorite. But feature detection cells are actually nerve cells. They're in the brain. And the brain is going to perceive angles and movement and edges based on how many neural responses are generated. So if you look at the left side with this angle, okay, this maybe has like 20 neural impulses, 20 action potentials. This angle has 6 or 5, okay, and then this angle has none. So that's how we're able to perceive is how many action potentials are generated based on that angle. Okay, let's get into theories of color vision, but before that, does anybody have any questions? Yes, Brecken.
Can you go over like the steps of which transduction
Sure. Okay, so here what happens in the retina, you're going to have the rods and cones, okay? So basically light goes all the way to the back, okay? And then I think the mnemonic device is the bipolar cells and then the ganglion cells. What you had to picture, and I have a picture of it just on here, is picture a polar bear with a lion on its shoulders. If you picture a polar bear with a lion on its shoulders, it's going to be bipolar cells. The ganglion cells leave the eye. Okay, and that's how transduction happens. Okay, so the theories of color vision. Hue is another fancy way of saying color. Okay, and we have two theories. Both theories are correct. We have the trichromatic theory and the opponent process theory. So trichromatic says we have 3 cones. And here are the primary colors for light. They're different than for paint. Okay, blue, green, red. Okay, and there's going to be a different combination depending on the wavelength input. Okay, this best explains color blindness. Okay, so again, this best explains color blindness. If my green cones don't work, I can only see blue and red. The opponent processing is their opposing colors, okay? And this is going to explain negative after images. So when we looked at the flag with the opposing colors and then we looked at the white screen, we were able to see the red, white, and blue. The opposing colors are red, green, blue, yellow, black, white. Okay, so just like opponent process can't explain color blindness, trichromatic can't explain after images. So that's why they both work together. And then I'm just quickly look at binocular cues. The big thing here is that binocular cues need 2 eyes, and there's 2 binocular cues. So retinal disparity, the message coming to our eye is different to each eye. And then convergence, which is crossing your eyes. So a few things here. Retinal disparity. Now, if let's say I only had one eye that was working. Okay, I was blind in one eye. I could still see some depth. It would just be harder. Okay, because my binocular cues, based on how far, if something's farther away, the image is more similar in my retina. The closer it gets, okay, the more of a difference there is, so that my brain perceives that as depth. Okay, so that's going to be the biggest issue with one eye being blind. You'd have a harder time maybe like catching a ball, okay, because you wouldn't be able to tell. However, you'd still see some depth because we have our monocular cues. Okay, so the monocular cues, this is when I had you go around and take pictures, okay, or draw a picture, and this is just an example of 6 of them, and you can look those over and let me know if you have questions. Okay, another key part here is constancy. Our brain learns to perceive that even though the image changes on our retina or the brightness changes around it, that it still is constant. So I think the door example is the best one. So I know that when the door is closed versus open, the door doesn't magically shrink or get skinnier. Okay, what it is it's just changing. My perception of it is changing. The door angle is changing. So that's shape constancy. Size constancy. When the airplane flies up, I don't think that it's shrinking as it gets farther away. I know it's getting farther away. Okay, and then there's color constancy, which I didn't put on here, but color constancy is when the light changes and the color remains consistent. And then here's Gestalt psychology. So Gestalt is going to be here. These are similarity. Okay, so we see the green, yellow, green. Here we see continuity. We see a circle with lines. The biggest thing with Gestalt is this part where it says the whole is different than the sum of its parts. So basically what this is saying is that we like to look at things as a meaningful whole, and it's more important, like we have to look at how everything works together, not just as it is in individual parts. Because if one part isn't working, then the whole part isn't working. So it's not just like adding everything up. So like let's say for perception, I know all the parts, the eyes, the retina, everything. If my lens isn't working, okay, it's not just saying my lens can't accommodate, okay, it's going to affect the whole system and vision. Okay, so that's what Gestalt was really looking at. And actually, if you want to write this name down, Max Wertheimer is a name here. Max Wertheimer. He's the person who came up with Gestalt. Max Wertheimer.
So Gestalt is not a person?
No, Gestalt means like circle or something in German, but then people who speak German say it doesn't, but that's what I've been told. Yeah, Gestalt is like whole. Yeah. So Wertheimer would be something with sensation and perception. And also, too, he's one of the theorists because you had structuralism, functionalism, and then Gestalt psychology came about, and that would be him. So are there any questions on vision? That's going to be the main part of sensation and perception. Okay, I didn't go over illusions. I didn't go over... there's a lot of things that you could still look at here. I just try to hit the main points. Okay, so let's get to the other senses. This one will be a lot shorter, and then we'll get to states of consciousness. Okay, so the big thing here with the ear, we're going to look at hearing, is going to be, I like to break it down with outer ear, middle ear, and inner ear. Okay. And what we're looking at here is that the outer ear is going to be sound waves. And remember, we have two ears because that helps us locate sound. Okay, so if I was deaf in one ear, I would have a hard time telling where the sound is coming from. Okay, because if it's on my right side, it hits my right ear first, so then I know to look to the right. Okay, so sound waves. And then the middle ear, it changes to vibrations in the eardrum. Okay, the eardrum, the waves hit the eardrum and causes the vibrations down the ossicles. Okay, and then the oval window is attached to the cochlea. Remember, the cochlea is where transduction takes place. So you have the inner ear is where you now have neural messages. Okay, so again, the outer ear, sound waves, middle ear, vibrations, inner ear, neural messages. So what's going to happen here is that if I were to draw a line right here, okay, anything that is up to the cochlea, this would be conduction deafness. Anything that's the cochlea or the auditory nerve is going to be neural deafness. You might see it as nerve deafness, sensory neural deafness. Okay, so that is the differences there. Conduction deafness. Right. So with pitch, a low pitch is going to have a long wavelength. Okay, a low pitch has a long wavelength. A high pitch has a short wavelength. Okay, so what we're looking at here is with the lower pitch, this means the frequency is less because the wavelength is only 1. Here, with a shorter wavelength, the frequency might be 5 wavelengths. Okay, so lower frequency, longer wavelength, lower pitch. Okay, less intense colors if we're going to look at colors. Okay, and then actually no, it's not colors, that's amplitude. The wavelength then, or for a higher pitch, is going to have a higher frequency because there is smaller wavelengths. Okay, so we have two theories to explain how we perceive pitch. So something that's a high pitch is something that's going to sound like the high end of the piano. Something that's a low pitch would be the low end of the piano. So what we're looking at here, high pitches, is best explained by place theory. Okay, and what that is, if this is the base layer membrane, so pretend we're unwrapping the cochlea. Okay, if there's a C note, a high C, okay, this is going to be perceived on this place in the cochlea. So then the brain's going to say, okay, that's this pitch. Now, low pitches is best explained by frequency theory. So it's not necessarily where it's being perceived, okay, but how many action potentials are being generated, okay, how many frequencies are coming. So if I go back to this, okay, this wavelength, let's say let's just do an A, okay, let's say it's an A note, has one wavelength. That means it's going to be one frequency, where the F has 5. Okay, so the F is going to be 5 frequencies. So we know that the A is lower because of the one wavelength. Okay, so again, what it is high pitches are explained with where it is on the place on the cochlea. Low pitches is frequency, how many action potentials are being generated up the nerve. Okay, so my mnemonic for this is I think of a roller coaster. The highest place on the roller coaster, okay, I picture being on the highest place on the roller coaster, and then as I get lower, I increase on frequency, go faster. Okay, so then I know that high pitches are best explained the place on the cochlea, low pitches are best explained by frequency or how many neural messages are being generated. Okay, now we're going to look at pain, and actually I do want to go back because I realized I didn't do this. Right here in the ear are going to be the semicircular canals. Not a part of sound, but what the semicircular canals do is allow us to perceive our body positioning and balance. Okay, so if somebody ever has an inner ear infection, okay, they may have a hard time balancing, or they might have vertigo. Okay, that the fluid in that part of their ear isn't reading the rest of the body. Okay, so now let's look at pain. The gate control theory of pain is basically saying that there's a gate in the spinal cord, and that gate is going to be open. Okay, that means the message will get to the brain. If it's closed, that means that the message won't get to the brain. And the theory is really saying that that our spinal cord can only allow so much feeling to go through it. So let's say this man just hurt his knee. Okay, he's going to start rubbing it. Okay, if he's rubbing it, the spinal cord is going to allow that message to get to the brain, which means it has to block the pain message. Okay, so that's what that gate control theory is. There is some part 2 of expectations, okay, with this, but we're just going to focus more on the actual spinal cord and the gate. Okay, how many of you, think about that, how many of you have had a headache before? Okay, do you rub your head? Okay, and that helps it feel better because it's perceiving the rubbing of your head instead of the pain of the headache. Okay, and then the last 2 here is just to know that olfaction is smell and gustation is taste. The big thing here with the chemical senses is there's no transduction here because what happens, the molecule starts the neural process. Okay, so as soon as a smell molecule gets into the olfactory sense, it's going to trigger a neural impulse. Same with taste. Our taste buds are going to activate. And here is something too, when we look at the role in nature, okay, so food sources, avoiding predators, I want to just mention pheromones, okay, so social communication and mating. Okay, so pheromones are smells that are going to be released that are going to signal danger, are going to signal mating. So that's why I have this picture here. Okay, when let's say a female's in heat, okay, and a male smells another male, they may fight. Okay, because of the pheromones that are being released. When a male knows that a female is in heat because of the pheromones she's releasing. Okay, and that helps maintain the species because they have to know when to mate. And then something defensive too, with like you can smell a predator. All right, so any questions on sensation and perception? Okay, let's look at states of consciousness. I'm not sure we'll get to motivation and emotion, but I'll try. Okay, so states of consciousness, okay, are going to be, it's basically what is our level of awareness? Okay, how aware are we of everything? Now, this is a very small part of the test, only 2 to 4%. Okay, so potentially you could see only 2 questions on this. Okay, so we'll try to hit the big ones. First, circadian rhythm. Okay, the circadian rhythm is our 24-hour sleep-wake cycle, but I also want you to know it has to do with alertness. Okay, so if you can think about when you're most alert during the day. Okay, so for me personally, mornings are great, afternoons are awful. Okay, and then I kind of get a second wind. Is anybody, it takes a while, like it's not until after lunch that you really feel alert. Okay, and then maybe in the evening. So that's a big part with adolescence. So circadian rhythm, we could look at the role in jet lag, okay, that your circadian rhythm's off when you're traveling. You can look at shift work, okay, that we naturally want to be asleep at night. Okay, so those are some different things that can play into effect. Okay, and then the sleep stages, I don't know why it says 120 minutes, but we go to stage 1 is the first stage, and that's if I were to wake you up, you'd be like, I wasn't sleeping, okay, even though you might have been snoring. Stage 2 is where we spend most of our night because we hit that sleep cycle on the way down and on the way up. So it goes stage 1, down to stage 2, down to stage 3, up to stage 2, up to REM, down to stage 2, back down to 3. So the deep sleep is when growth hormone is released, and I want you to know what brainwave is associated with stage 3. Delta, deep, delta, deep, delta. Stage 2 has a particular brainwave too. I just shouldn't say a brainwave. It should be... Yeah, stage 2 has the sleep spindles. I guess it's not really a brainwave. It's something that happens in the brainwave. Okay, now if we go, I'm sorry to be backtracking. If we go back to stage 1, okay, really when you think alpha, you can think of awake and relaxed or the initial parts of stage 1. Stage 1 can also be theta. So I've seen alpha and theta. So I don't think that's really going to be on there. If I were to guess brainwaves, I would guess stage 2 sleep spindle, stage 3 delta, if they're going to have anything on there, just because there's a little bit more with stage 1. I see different stages. I went and looked at several places. Okay, and then REM sleep is your revitalizer memory. So REM is best for your brain. Okay, and then stage 3 is going to be good for the body, and that's what we get. That's that deep restorative sleep that we get at the beginning of the night. So REM sleep is also called paradoxical sleep because when my brain is really active, like I'm awake, okay, my brain is really active, but then my body is really calm. So my muscles are relaxed. I might have some twitching. Okay, my muscles are relaxed. My heart rate is internally I'm very calm, or externally I look calm. Internally it's very vibrant and awake. Okay, so which stage would sleepwalking occur? 3. So stage 3 has sleepwalking, has bedwetting, also called enuresis. It has sleepwalking, enuresis, night terrors are in stage 3. What stage would you have a nightmare in? REM, because it's a bad dream. Sleep apnea can happen in any. Narcolepsy is falling asleep when you don't want to, and then insomnia is not sleeping. So now when we look at, and I should have put this on here, 2 theories of why we sleep. So before we get to manifest and latent content, the 2 theories about why we sleep. We have the restorative or repair theory of sleep. Okay, we sleep because we deplete resources throughout the day, so our sleep actually restores everything. And then the adaptive theory of sleep. So adaptive theory is that we evolved to sleep at night for protection because we did not evolve to see at night. Okay, so I sleep at night so I'm safe. Okay, so now our circadian rhythm is set that when it gets darker out, we want to be sleeping. Okay, we've evolved that way over time. Okay, so you have repair and adaptive theory. Now, the dream theories, okay, we have manifest versus latent content. Manifest is how is the dream manifesting itself. It's a storyline. Latent is the symbolism. So when I wake up and I tell someone my dream, they're going to interpret the latent content later after I wake up. Who did this theory? Freud. This has Freud all over it. Okay, and this is one that I added so if you were at the other review, I added this one in. There are different theories of dreams, which is the activation synthesis theory. Okay, so basically our brain is really active during REM. So that means that there's a lot of firing in the neurons. So it might trigger memories, and then our brain likes things to be a meaningful whole. So if I have a memory of running, and I have another memory of the woods, my brain might put it together that I'm running through the woods, away from a predator like a zombie. Okay, so it just kind of combines. Do you ever notice that your dreams may jump a little bit? Like all of a sudden you're here, then you're here, then you're here. That could just be your brain putting together all the meaningless bits of information. So activation, your brain is active, synthesizing, putting it together into a story. If you synthesize, it's kind of like summarizing. Okay, and then here's the sleep disorders. Hypnosis, you have two theories, so social influence and divided consciousness. Basically here, are you acting it out? Or are you actually in a different state? Okay, those are the two theories. Okay, so what we're going to look at now with drugs, this is something too that I think I just added, is just the difference with looking at like tolerance is maybe when somebody first drinks, they need 2 drinks. Okay, if they continue to drink, they might need 6 drinks to get that same effect. So you're building up, you're having less response to these stimulus. Okay, and then we have dependence, either physical or psychological. Okay, physical is where people would experience physical withdrawal symptoms. So on Sunday, I didn't drink enough coffee. So what happened Sunday night? I got a headache. Okay, so I have a physical dependence to caffeine. Okay, so I got a headache because I didn't drink my 7 cups of coffee. Okay, psychological, I wish I were joking. Psychological dependence. Okay, the need to, it's more of that psychological need. So I'm stressed. Okay, if somebody's stressed, they may feel like they need to smoke. Okay, or if somebody's stressed, they may want to, do any drug. Okay, they can't cope with the stressor, so to cope, they numb themselves by doing the drug. And then withdrawal is actual physical reaction. And then here's the categories of drugs. I think too, if you go back and look at the neurotransmitters, do any of you have your neurotransmitters notes from the other day that we did in class? Why don't you go to those? Okay, so when we look at the neurotransmitters here, the depressants, okay, are going to be an agonist for GABA and an antagonist for glutamate. So that makes sense because if it depresses your immune system, it's going to mimic your primary inhibitory, and then it's going to stop your primary excitatory. Okay, so it's a double depressant, essentially. It's affecting those neurotransmitters. Okay, stimulants, you need to associate with dopamine. Okay, so if somebody's doing dope, they're getting really high, dopamine. Okay, so, when I say high, that's like that euphoric feeling that's associated with stimulants. Okay. Now, hallucinogens, remember the serotonin song, serotonin, serotonin, LSD, ecstasy, they go together, tripping forever, LSD, ecstasy. Okay, so serotonin is associated with the hallucinogens. Narcotics, heroin and oxycontin, these are going to be endorphins. Okay, morphine, because it relieves pain. Okay, and it does create a euphoric feeling as well. Marijuana, I don't know this off the top of my head, and I haven't really seen much, but it's kind of its own category because it's crossing. It does, I think, bind to specific receptors that we haven't talked about. Okay, we've talked about very generalized, but you can get into like a lot more in depth. And then here we looked at like antidepressants are going to block reuptake of serotonin. Antipsychotics are going to block dopamine receptors because there's too much dopamine. Okay. Any questions on consciousness? Yes.
So would heroin also work on your endorphins?
I'm sorry?
Would heroin work on your endorphins?
Heroin does work on your endorphins, yes. So, and there is more. I mean, there definitely are more that, I mean, they can get into these different, like D2, D1, and all that kind of stuff. Overall, I want you to know that heroin, morphine are going to affect the endorphins, yes, because they're the body's natural painkiller. Okay. So I didn't think we'd get this far. So I guess what I'd like to do here is just talk about the main things you'd probably see with motivation and emotion. The first is going to be the theories of motivation. Okay, so the theories of motivation are going to be like biological, so instinct. Okay, so I have a bird that built a nest. That is an instinct that they build nests in the spring so that they can lay their eggs. Okay, I have drive reduction. I'm thirsty. What does that mean that my body needs? Water. So I am going to be motivated to drink water because I'm thirsty. I want to reduce the drive of thirst. Okay, I also can look at the arousal theory, or optimum arousal theory. Why do people want to go skydiving? Why are people curious? Why do they want to look at and explore different things? Okay, and then the theories of emotion. I have a mnemonic for that. So I think I had shown it to you in class yesterday. The James Lang, A before E, arousal before the emotion. Two-factor theory is the cognitive label and the cognitive label and physiological response. Okay, and I'm hoping the rest is more straightforward with this, but I can take any questions, anything on here you want me to go over. If you come to other reviews, I don't go this fast. Okay, what we just did was basically 3 days of stuff, and there's more time for questions. Okay, so if you don't have any questions, I'll see you in class today. Hey, you just got to get through today. Then you have tomorrow off. And you can just study psychology all day. It's going to be great. Huh.
So what are two upper level psychology classes? Is it more just specialized on like a certain talking about everything?
Yep.
Okay.
So did this record or no?
You said all these presentations are in psychology?
Yes, this is in the before school review.
I was gonna say, because I wanted to draw like the ear thing, but
Yeah.
I'm not a good drawer. So
No. Yeah, everything's on Schoology. Yep. Yeah, so once you start getting into upper level, you could get into, neurobiology, so you'd look at biology, but then you could probably take courses that are just on, the physiology of the brain. Actually looking at, organic chemistry more so would definitely be along those lines. But, yeah, the classes that I took a developmental psychology, an abnormal psychology, and then you could take every unit we've done, you can take a course in. And I just try to teach you in 18 minutes. You know what I mean?
Oh, it's not like you take it off.
No, I know it wasn't. But I'm that's what's cool is there's so much more out there that we aren't even able to get into.
Do you major in psychology?
I definitely did not. I majored in history. I really wish I had, but
You just took like psychology courses?
only three classes.
9 credits.
Correct. Now, if I were to go back and do it again, well, my advisor were history professors. So they're like, no, you need a major in history because that's probably what you're going to teach. Now, and then my first year literally graduated on Sunday and interviewed Tuesday, got a call Thursday, and they're like, how do you feel about teaching 5 classes of AP psychology? I'm like, I just got a history degree. Sure, yep, I'll do it. So it's way better, but
I have a question.
Yeah.
Does that thing call for if your heart's beating and you're not scared, you're like, oh, I think I'm scared.
the two-factor theory, the Schachter Singer. Yep.
Okay. And then do we get a note card on the final?
No.
Or